All right, so we have been doing derivatives. Last time we talked about displacement, velocity, acceleration. These are concepts of physics, but physics is essentially just maths. If you really think about it, if you go down to its bare bones, physics is just maths. If you keep going down this rabbit hole, I guess math is just philosophy, but yeah, you must be wondering why we're doing physics. It's because this is part of the math curriculum here. And I'm sure you'll do this as well. I'm not sure you'll do this in grade 11 or grade 12. Just for now, know that velocity, displacement, and acceleration are related to one another. I think the most important thing is to know when you plug one in here. Like right now, they've given us two different x values or t values. When do we plug one in there, and when do we plug one into v prime of t? I think that's the question. So here, explain and discuss the difference in velocity at times t equals 1 and t equals 5 for this function. Alrighty, so v1, let's just plug it in. v1 is 2 minus 1, that's 1. v5, it would be 10 minus 25, it would be negative 15. What does this mean? At time 1 second, the velocity is positive, right? If you know what velocity is the slope of the displacement curve. So at time 1 on the displacement versus time curve, we don't know what it looks like, but we know that at this point, the slope is 1, and that's what this is. This is the slope of the displacement versus time curve at time equals 1. So are we going further away from the origin, or are we going towards the origin? You can think of this as, well, you know where the origin is, but you can also think of this as the ground. So at t equals 1 second, are we going away from the ground, or are we going towards the ground?
Away.
Away. And at t equals 5, we go somewhere, we hit a peak, a vertex, we don't know where it is. We could probably find it. It's going to be, yeah, it's not that difficult to find. But at time 5 seconds, we're coming back down, and right now the slope here, the slope of this tangent line is negative 15. Are we going away from the ground or towards the ground?
Towards.
Towards the ground, and that's the difference between a positive velocity and a negative velocity. You can think of negative velocity as going back towards something, whereas a positive velocity is going away from something, usually the x-axis. Determine the second derivative. Okay. Remember, first derivative is you take it once, second derivative is you first take the derivative and then you go one more level deeper. It's a little bit annoying, but it's all good. It's manageable. So this is gonna be f, this is gonna be g. What do we use to solve this problem? How do you find the derivative of a fraction? You're
Use
gonna,
the quotient rule.
yeah, use the quotient rule. Okay, what's the derivative? What's f prime of x, if you remember what the formula was? There's a minus and there's a g squared on the bottom. It's f prime g, the derivative of the first function times the second function as it is, minus the derivative of the first function as it is times the derivative of the second function. What will that be here?
Two times x plus 1.
Yes. Minus 2x times what? G prime is just 1. The derivative of x plus 1, well, plus 1 is a 0. The derivative of x is a 1. So all over g squared, so all over x plus 1 squared. Because we have to take it one level deeper, we're going to expand this. And I clean it up. Always clean it up because it's way easier to take the derivative of something that's cleaned up at 2 over x plus 1. Now this one I'm going to cheat because I don't want to be using the quotient rule no more. So this is f prime of x. You can do this. You can throw the exponent upstairs, make it negative, and the number in front of is a 2. So this is neither a product rule nor a quotient rule problem. You do have to, oh yeah, chain rule is also 1. So this is just a straightforward derivative. What will be the derivative of this function?
You bring the -2 down.
Yep, so it'll be -4 x plus 1 to the -3, and the derivative, the bracket derivative is 1, so you can ignore it. And that's the final answer. That makes sense?
Mm-hmm.
So that one was a quotient rule problem, was a little bit annoying. G is also, actually G, you can also move this up. You can use the quotient rule, that always works. You can say this is F, this is G, F prime would be 0, yada yada. But you don't have to use it if you see it. I'm gonna move the x squared up because I am not a fan of fractions. Because on fraction you have to use quotient rule. So now look at this, y prime. Derivative of x squared is 2x. Derivative of x to the -2 is -2x -3. No quotient rule required. Now let's go one more level deeper. What's y double prime? What's the derivative of 2x?
It's 2.
It's 2, easy peasy. What's the derivative of 2x to the -3?
It's 6x to the power of -4.
6x to the power of -4 is perfect. And there we go. So something like this, you don't have to use quotient rule if you see it. Let's go to h. So even before we do anything, you don't have to do this, but just to see it, I'm going to write it as to the power of 1 over 2. What's the derivative of this? So 1 over 2 comes, right? Like that.
Mm-hmm.
3, 6, and you take 1 away. So minus 1 over 2 times, what do we multiply this by?
By 3.
By 3. So it'll be 3 over 2 square root 3x minus 6. No, I'm not gonna do this yet. So, because we have to go one level deeper. So 3, I guess we can move it here. So this becomes 3 out of 2. What's g double prime of x? What's the derivative of this? So it's simple. This thing comes here, right? This thing comes here. Boom. So 3 over 2 times 1 over 2 is negative 3 over 4. 3x minus 6, and then you take 1 away from this, it becomes negative 3 over 2. Negative 1 over 2 minus 1 is negative 3 over 2. Times, now the chain rule, we multiply this by 3. So the final answer would be negative 9 over 4, 3x minus 6 to the negative 3 over 2. Okay?
Mm-hmm.
I and j are super simple. Y prime would be, again, 3 comes in the front. So 2x plus 4 squared times what? What's the chain rule component?
It's 2.
Yep. So that's a 6. 2x plus 4 squared. Go one more level. Second derivative would be 12. 2x plus 4 to the 1 times 2 again. 24, 2x plus 4, and you're done. Easy peasy. J is the same thing. So double derivatives, doesn't matter. We can even go triple, quadruple. Polynomials will eventually stop. So this is a polynomial. By eventually stop, I mean that all the derivatives are going to be 0. Let me open this. I'll show you. This is 48x plus 96. So this is still y double prime. We know this is a polynomial. It's a cubic polynomial. Y triple prime would just be 48. Y quadruple prime would be 0. And from here, everything is 0, right?
Mm-hmm.
Like that. These don't mean the Roman numerals 1, 2, 3. Just means single prime, double prime, triple prime. This is something that I've come up with myself. It means the fourth derivative. You probably written like this in a textbook, but I'm going to use this notation. All right, K for communication. Nope, communication starts with a C. So what's K for?
Knowledge.
Yep. Describe the motion along a straight line. All right. Find the velocity and acceleration functions. Looks difficult, not that difficult. So here, D. So it's asking us to find velocity. We know velocity is the first derivative of the displacement function. So we just have to find s prime of t, which will be 2t minus 3, yeah?
Mm-hmm.
So 2t minus 6. At is the second derivative of the displacement. So we just have to take the derivative of this, which means it's 2. Done. So that's for D. It's the same question. It's just asking you to find the second derivative. So for E, the first derivative would be 1 over 2 t plus 1 negative 1 over 2 times 1. The second derivative would be, we've done this many times. This comes down, take 1 away from that. Negative 3 out of 2 times 1. So you don't have to write the times 1. For F, you'd use the quotient rule. So this is position versus time curve. When is the velocity 0? Remember what velocity is. It's the IROC, the slope of the position time function. So we need the slope to be 0. At which time is the slope 0? The slope
3.
means the tangent line, yep. Right here it's 0. Right here it's 0. Right here is 0. So that's the answer to I. The second one, when is the velocity moving in a positive direction? Means the tangent has to be positive. So it's going to be positive right here. If you draw tangent lines, you'll see they're all positive before this slope 0. So time less than 3 seconds, positive. Time less than 3 seconds, positive. And also here, after 7 seconds, it's all going to be positive, okay? That's where it's positive. Negative would be when the tangents are negative. So right here would be negative. Right here in the middle would be negative. And those are all the questions. So this one is just asking you to, can you draw tangent lines, is what that is. Nothing else. Okay, this one. Again, they've given us a position function. S is always for position. And they're asking us part A, determine the particle's velocity and acceleration at any time t. So what's our plan of attack? How do we do part A? Any ideas? They've given us a position function. How do we get the velocity function from it?
You find the first and second derivative.
Yeah, that's it. You just find s prime and s double prime, and you're done. So for A, s prime is going to be t squared minus 4t plus 3. S double prime would be the derivative of this, so 2t minus 4. Done. Easy peasy. B, when does the motion of the particle change direction?
When the slope is 0.
Yeah. Where's the slope 0? So we have the slope function. We are gonna set it equal to what? 0. We have a quadratic trinomial. How do we solve a quadratic trinomial?
You use man.
Use man. So I'm gonna remember, multiplies to the first times the last, 3. Adds up to the middle, minus 4. What are the numbers?
-3, -1.
-3 and -1 works. So again, if the coefficient A is 1, you can write this as t minus 1, t minus 3. So this will be t equals 1, t equals 3. So at 1 and 3 seconds, there are turning points, and that's where it will change direction. Part C. When does a particle return to its original position? What does that mean? What are we looking for in part C? What is the original position? If you think about it. What's the y-intercept here? At t equals 0, what's the y value? Notice it has no numbers attached.
So it's 0.
It's 0. So at time equals 0, he was at the origin. Yep.
Mm-hmm.
The question is asking us, when is this person going to come back to the origin? So if you think about it, this thing, we can pull out a t, right? Do we know any zeros if we pull out a t? We know if you pull out a t, we also knew this because the y-intercept is 0, he's going to go through the origin. So at time equals 0, he's here. And then we don't have the other 2x intercepts. So this will be this minus 2t plus 3. So I'm going to find this point and this point. So let's set this equal to 0. 1/3t squared minus 2t plus 3 equals 0. How do you solve this quadratic trinomial?
You use man.
You could, but man doesn't do very well with fractions. So let's see if we can use man. What does it multiply to? It'll be the first coefficient times the third coefficient.
To 1.
to 1. So what are the numbers that multiplies to 1 and adds up to 2? Probably doesn't exist. Let's use a different approach. Again, this may not work as well, but I'm going to give it a shot. I'm going to pull out 1 over 3. T squared. What am I left with if I pull out 1 over 3? In other words, what's negative 2 divided by 1 out of 3? Because here it's a 1 because we did 1 out of 3 over 1 out of 3. That's why it was a 1 here. For here, we're going to do negative 2 divided by 1 out of 3. Does the 3 go to the second level or does it go to the top level?
The top level.
So this will be minus 6. Same thing with this one. It'll be 3 over 1 over 3. That this 3 would go to the top level. It'd be 9. Okay?
Mm-hmm.
Now this is way easier to man than the last one. Because now it multiplies to what? 9, negative 6, negative 3, negative 3. Yeah. So it'll be 1 over 3, t minus 3 squared equals 0. So the other x-intercept is at 3. So there we go. At 3, there is another x-intercept. So that's the answer to this one. When does the particle return to its original position? When time is 3 seconds, the y value is 0. Okay? So that's the answer to this question. Again, we're nothing too complicated. It's just quadratics. It's just factoring and man. All right, I'm starting to get bored. Maybe this one? All right, let's try this one. So someone's throwing a rock or an object from a certain height. Its initial velocity is 40 seconds. Okay, I don't know if that helps us. Let's try graphing this. ST. How do we graph this? You see this equation, how do you graph this? No? We're graphing a quadratic. It's not too difficult, okay? Here, look at this. Just first identify that it's a quadratic. I'm just gonna write it down in descending order of degrees of powers. So this is what we have, right? To graph a quadratic, you need 3 things. You need the x-intercept, the y-intercept, and the vertex. These are all the things you need to graph a quadratic. We already know the x-intercept and the y-intercept right now. Y-intercept is always the constant that's added towards the end. So what's the y-intercept here?
0.
0. How many roots can a quadratic have? How many x-intercepts can a quadratic have? How many times can it cross the x-axis? If you think of a quadratic, right? It can only cross the x-axis a maximum of how many times?
2.
2. So we already know one of the zeros is at 0. We're just concerned with finding the other 0. This is how you do it. 0 equals t negative 5t plus 40. T equals 0 is what we have right here. That's the first x-intercept. For the second x-intercept, you want to set this bracket equal to 0. So 5t plus 40 equals 0. T is 8. So at 8, 1, 2, 3, 4, 5, 6, 7, 8, we are right back here. We have the x-intercepts of 0 and 8. What's the x-intercept of the vertex?
It's 4.
It's 4. How do we find the y-intercept of the vertex? We plug 4 back into the equation. So this is called your axis of symmetry. To find the y value of this vertex, we're going to plug 4 right back in here. So S of 4, or you can plug it in here. It doesn't really matter. They're the same equations. So that's 160 minus 5 times 4 squared. It's 80 meters. So at 4, 20, 40, 60, 80. Let's say that's 80. And we have our sketch. We're not concerned about the negative x-axis, and we're not concerned about underground. This is our ground. X-axis will always be the ground level. Was that difficult to graph this?
No.
Because once you have this, it's a 10-second answer, not even 10 seconds. When does the object stop rising? When does the tangent stop becoming positive? See these tangents here? When do they stop becoming positive is the question.
And the time is 4.
Yeah, t equals 4. What's the maximum height? 80 meters. Done. Easy peasy. Here's another question. It's not a quadratic. A there is for Applebee's. No, it's not. What is it for? What's this A for?
Application.
Application. So this would be, usually A would be like a real life problem. Usually they try to throw something real life based. Now we don't have a polynomial, so it's not going to be that easy to graph. All right, let's see what we can do with this one. Calculate the object's velocity and acceleration at any time t. What is part A asking us to do?
The first and second derivative.
Yep. So s prime of t, which will be the velocity function. This one you have to use a product rule. There's no other way around it. So fg. It's f prime g plus fg prime. Same thing as the quotient rule, but with a plus. What's f prime?
You bring the 5/2 down.
Mm-hmm. What's the new power?
It's 3/2.
It's 3/2. So that's f prime, g as it is, plus f prime, sorry, f as it is, sorry, and the derivative of g. What's the derivative of g?
1.
-1. Minus t becomes -1. So like that. I'm going to move this minus sign here. So like that. That's s prime of t. And then we got to go one level deeper. S double prime of t, which is the derivative of the velocity function. And that'll give us the acceleration. So again, same kind of idea. Have to use the product rule. I'm going to say this is f. I'm going to say this is g. This one is it has a minus sign, so that one we can probably find it right now. That's just going to be 5/2 t 3/2 is what that is. Yeah. For these two though, we have to use a product rule again. So this becomes 5/2 times 3/2, 15/4. And the new power is 1/2. So that's f prime, g as it is, plus f as it is. So this times g prime, which is still -1. So all that does is this plus becomes a minus sign. So minus 5/2 t 3 over 2, like that. And there we go. That's the second derivative. Cool?
Mm-hmm.
What we're going to do is I really don't want to be graphing this rational function. It's not going to be precise by any means. So we're going to use technology to graph this function. We could definitely graph it by using a table of values. But it has a lot of weird exponents, so it's not going to look nice. So what we're going to do is we're just going to plot this. And this is what it looks like. So let me pull up the plot. Actually, let's label the numbers as well. So we know this, this, this. This should answer every question. All right. Part B, after how many seconds does the object stop? Look at the graph. That's a position time graph. Object stopping means the thing is going to be, you know what I mean. What's the answer to B? When is the velocity 0?
When time is at 5.
When time is 5. Done. Part C, when does the motion of the object change direction?
After 5 seconds.
Done. When is the acceleration positive? Okay, now that one is not as easy. E is easy though. What's the answer to E?
When time is 7.
Yeah, when time is 7. But now the question is part D. When is the acceleration positive? I guess what we could do is we could set, this is our acceleration function. We could set an inequality like this and try to solve for t. I'm not doing that. That'll be way too complicated. Trying to solve for t there. Would it be though? Yeah, it would. Actually, I see something. Still would be tricky. No, I didn't see it. So now the question is, when is the acceleration positive? This is how you could solve it. But that doesn't look easy because you have multiple functions here combined together. If it's one function, it's easy to deal with. But you have a root function, here you have a linear function, and here you have an extended root function. So that won't be easy. What we can do is we can use this plot to derive this. Remember that this is the acceleration versus time curve. When we take the derivative of this, so our interested numbers are 0 and 7. At time 5, the slope is 0, right? Agree with that?
Mm-hmm.
So the velocity function at time 5 is going to come right here. Between 0 and 5, is the slope increasing or decreasing?
It's increasing.
What about from 5 to 7?
Decreasing.
Decreasing. From 5 to 7, it's going to look like this. From 0 to 5, again, it's increasing, but in a decreasing manner. If you look at this graph, if you were to draw tangents here, what's happening to the tangents? It's decreasing until it becomes a 0, yeah?
Mhm.
So before 5 seconds, the velocity was positive, but it was increasing in a decreasing manner. It was increasing in a decreasing rate. So that means over here, it's going to be very close to 0. So it'll probably look like this. So that's the velocity versus time curve, okay?
Mm-hmm.
What will A versus T look like? What's the slope of this line? Is it positive or negative?
Negative.
Negative. So A versus T would probably look something like this. And you're done. A versus T is a slope of V versus T, which is a slope of S versus T, okay?
Mm-hmm.
So this will be the easiest thing. Trying to solve this is, let's actually try it. We'll do some proper algebra here. So what I'm gonna do here is I'm gonna open this bracket. So this will be 15 over 4, 15, what's 15 times 7? 105. 105 over 4, I'm opening this bracket. T 1/2 minus 15 over 4, 3 T 3/2. These two are like terms, so you can say minus 10, like this. Now there's something we can pull out here. We can pull out T 1 over 2, okay?
Mm-hmm.
Over here would be left with 105 over 4. What would be left with over here? What's the power of this T? You want to think of it like this. You have this, we're taking this out. What are we left with? And remember, use the exponent laws. This goes up here, you subtract them. So it'll be T by itself. Minus. Same thing here. This will be 20T over 4. So what this means is either this is bigger than 0. So when is the square root function? When are the y values of this function bigger than 0? When time is bigger than 0. That's one solution. The other solution is this. So that's negative 5T over 4 is equals to 105 over 4. This and this cancels out. T will be, again, we're setting this bracket equal to 0. So T will be 21 seconds. So there we go. And that'll be the answer. Last time we didn't know exactly what the time was, but here we can solve the time precisely. Okay?
Mm-hmm.
Usually the graphical approach is better. Okay, where's my book go? All right. Not too worried about these questions. All right, let's move on from this. We are given what type of a function do we have here? How would you describe f of x? Is it a trig function? Is it a rational function? Or what? Is it a polynomial?
Yes.
Yeah, it's a polynomial. So polynomials are usually easier to deal with than any other type of function. It's a cubic polynomial. The only thing we do know is the y-intercept. Remember, negative cubic polynomials start here, end here. We know the y-intercept. So the graph could look something like this. We don't know what it looks like. The only thing we do know is it's opening in this fashion, and we know the y-intercept. The question is, extreme values means the maximum or the minimum, the lowest or the highest value. Between -1, let's say this is -1, and 5, in this chunk, what's the maximum value? And what's the minimum value? That is the question. That makes sense?
Mhm.
You understand the question, right? Don't know if this is doable by hand, but we can definitely find this. How would we go about finding this x value here? What's happening at this x value? Think about it in terms of the slope.
It's 0.
It's 0. The slope is 0, right? So if we find f prime of x, the slope function, set it equal to 0, we can find this x value. And using that x value, we can say, well, here is a maximum, or here is a minimum. Yeah?
Mhm.
So let's find that. So f prime of x, so that'll be -6x squared plus 18x equals 0. Can we pull anything out?
An x.
I'm going to pull out a -6x. Always pull out the maximum things you can, like that. So at x equals 0, there's a turning point. And at x equals 3, there is a turning point. Okay?
Mhm.
Now let's see what f of 0 is. F of 0 is a 4. So now we can enhance this graph a little bit. We know we were coming from here. We know we'll end down here. But now we know when the x value is 0, the y value is 4. And then we can also find f of 3. Quick maths, -2 times 27, -54 plus 9 times 9, 81 plus 4. 81 minus 54, okay. And at 3, it's going to be 31. What else do we know? We know that both of these are turning points. There's a turning point right there. There's a turning point right there. At -1, quick maths here, 13 minus 2 plus 2 becomes 15. At -1, the y value is 15. Okay, what's the maximum? Again, we're only interested right here. We're only interested between -1, and I guess I could find the y values here. I'm going to need a calculator for 4 and 5. -2 times 64 plus 9 times 16 plus 4. At 4, the y value is 20. Remember, over here it's 31. And at 5, the y value is negative something. At 5, the y value is -21. What's our maximum value and what's our minimum value? And when I say that, I'm talking about the y values. Right in this chunk, what's the biggest y value? What's the smallest y value? This is our biggest. Max equals 31. What's our minimum?
-21.
Done. So this happens at 5, and this happens at 3. There we go. That's the answer to this question. So this one, definitely tricky. Let me see, there's another problem like this. But usually the first thing you want to do is you want to find the turning points, because one of them will for sure be the minimum or the maximum. So this is what the curve looks like. This is what we had as well. Yeah, if we know these two, we know the direction it's coming from, we can kind of narrow it down where the maximum and the minimums are. Okay, here, let's try doing it for another function. It looks tricky, but I don't think it's that tricky. But this one, we can definitely graph it. Last time it was tricky to graph because we couldn't pull any x's out, and cubic functions, if you remember, the way to graph them is you have to factor it. You'd have to use the remainder theorem. It gets super tricky. This one, we don't have to do any of that to graph it. Why not? How come this is so much easier to graph? If you look at the function, because we can pull out a t. That will make it a quadratic. Yeah?
Mm-hmm.
So we don't have to worry about graphing cubics. Quadratic, we can do all day. So we're going to set this equal to 0. So we have t, and now let's man the other bracket. Multiplies to negative 21, adds to positive 1. What are the numbers, if they exist? The only thing that multiplies to 21 is 7 and 3, right?
Mm-hmm.
So this approach doesn't really work. We can't man this. We have to use the quadratic formula. This is what the quadratic formula says. Your x-intercept is negative b plus minus b squared minus 4ac all over 2a. The coefficient of this is a, the coefficient of this is b, and the y-intercept is your c value. And this formula, get used to it, you're going to be seeing this a lot. So it'll be negative 1 plus minus 1 squared minus 4 times negative 1 times 21. I'm just plugging in all the values to find my two x-intercepts. 2. Plug that in. I'm going to do a little bit of cheating here to save time. Where is my graph? So let me just plug the graph in there. I'm going to plug this in there to see what the calculations are. So negative x squared plus x plus 21. So the two x-intercepts are negative 4.11 and 5.11. So that's what it would have given us. So therefore, we know how to graph this function. It's coming from here. It's a negative cubic. It's going here. There's no x-intercept, there's no y-intercept, means it has to go through the origin. And the other 2 points are negative 4.11 and 5.11. So it'll look something like this. Yeah. That is our function. We need to find the minimum and the maximum between 0 and 5. So we're looking at this chunk right here. Not even 5.11, but 0 to 5. Do we know the maximum? Or is there a way we can find the maximum? I'll even erase everything else. So now think about this. I guess we didn't really need the quadratic formula. I guess we did because it helped us graph it. Now here's the question. This point is 0, 0. This point is 5, but that x-intercept is at 5.11, okay? Maybe I'll draw it like this. So we're interested in this bit. The x value here is 5. The x value here is 5.11. That's where the y-intercept, that's where the 0 is. Anyways, if you look at this, where do you think the maximum is? There's only one place. Right here. What's happening here?
Slope is 0.
Slope is 0. Let's find the slope. C prime of t equal to 0 equal to negative 3t squared plus 6t plus 21. 0, take out -3, t squared minus 2t minus 7. Two numbers that multiply, again, this is annoying. Two numbers that multiply to -7 add up to -2. Doesn't exist. The only thing that multiplies to 7 is 1 and 2. So we're going to use Desmos quickly to find the 2x intercepts. So -3x squared. By hand, you'd use the quadratic formula. Right? I got the 2x intercepts of this quadratic. So it's either at -1.8 or at +3.8. What does this x value look like? -1.8 or +3.8?
Positive 3.8.
There we go. So right here at +3.8, there's a maximum. So when t is 3.8, you can plug c of 3.8. That's going to be the maximum. That is easy. Oh, it wasn't that easy, but that one was obvious because there's a turning point there. So the slope would be 0. The minimum is tricky, though. You just have to be able to see it. It's on this graph somewhere. It's already written. What's the minimum y value in this box? The smallest y value.
0.
0. Done. T equals 0, y is 0. That's the minimum, and this is the maximum. Let's look at this one. We're given some function. It's asking us minimal intensity between 0 and 14. Okay, let's graph this. They graph it as well, but they pretend like they don't. 16. I'm gonna graph this to see. We're gonna see what's going on here. So this is the graph. The question is between 0 and 14. So we are only interested in x-axis between 0 and 14. We can go by 0.5. So this is it. 0 to 14, wherever that may be. Where is the lowest y value? Do you see it? It's right here. 2,6. Yeah?
Mm-hmm.
But how do we find it is the question. We know what it looks like. We know what it looks like on a graph, but how do we find it? What do you notice about that point? It was something like this. It was coming this way, and then it like went like this. And that point was 2,6. What's special about this point?
The slope is 0.
The slope is 0, and that's what we've been doing all day. So even if we didn't have the graph, even if it was a funky looking, complicated, multiple function having graph, set the slope equals 0. I'm going to find I prime. You know how to do this. You need to use quotient rule. So f prime g minus, okay, this is harder than I thought. F g prime, which is a 1, all over t plus 2g squared. What is the slope there? 0. How do we solve this for t? It looks complicated, right? It's not. Multiply both sides by the denominator disappears completely. 0 times the denominator is 0. So we can pretend like we don't even have a denominator. And when you FOIL this, you will get a quadratic. And by now, quadratic should be nothing complicated. Boom, like that. Let's collect like terms. 2t, 2t gone. 4 minus 16, -12. 2t squared minus t squared plus 4t. Two numbers that multiply to -12 add to 4. 6 and -2. Yeah?
Mm-hmm.
So we get equals to t minus 2 pt+6 equals 0. And when you solve it, well, there's a turning point at 2. There's a turning point at -6. -6 is not part of our domain. Boom, boom. 2 is the answer, and we knew 2 was the answer because 2 was the answer, right? That's the vertex. That's where it was. So all you have to do to find the vertex is to set the first derivative or the derivative equal to 0. And this is a method widely used in curve sketching, which is going to be a topic for another time. All right, let's call it there.
Okay, thank you.
See ya.